Problem number 4. Consider a parametric curve. X of t is t cubed minus t. Y of t is 4t squared, where t is all real numbers. Find the point, x naught, y naught, where the curve crosses itself, and find the two tangent lines to the curve at that point. So, when does this curve intersect itself? Well, it intersects itself when there's two different t values. Let's call them t1 and t2, where we have x of t1 is equal to x of t2, and y of t1 is equal to y of t2. At these two different times, the x coordinates and y coordinates are exactly the same, so the particle is in exactly we're thinking of particle moving along the curve, the particle is in the exact same place at two different times. So let's plop in t1 and t2 into here. And so from the first equation, x of t1 would be t1 cubed minus t1 is equal to 2. Plop in t2. t2 cubed minus t2. And when we plop in t1 and t2 in for y, we end up with y of t1 is 4t1 squared is equal to y of t2, 4t2 squared. Should make it clear that we are going to require that t1 and t2 are different. That's going to be important in just a moment, because let's solve this equation here. Well, we can cancel out 4's. t1 squared is equal to t2 squared. And so if we have t1 squared is equal to t2 squared, this tells us that t2 is equal to plus or minus t1. But if t2 is equal to plus t1, well, that's violating the, t1 and t2 have to be different condition. So this tells us for sure that t1 and t2 are negatives of each other. Okay, so what are we going to do now? Let's take t1 is minus t2. So I'm going to substitute that in over here. So what do I end up with? t1 is minus t2 cubed minus t1 is minus t2. That still is equal to t2 cubed minus t2. This is minus t2 cubed, and that's a plus t2. So that's equal to t2 cubed minus t2. If we add t2 cubed to both sides and add t2 to both sides, we end up with 2t2 is equal to 2t2 cubed. And cancel. What are we left with? t2 is equal to t2 cubed. Dividing both sides by t2, we can divide both sides by t2 because we know that t2 is not equal to 0. If t2 were equal to 0, t1 would equal minus 0 would also be 0. We'd have two different things that are 0. We don't want that. So 1 is equal to t2 squared. And so what do we conclude here? t2 is equal to plus or minus 1. So t2 is equal to plus or minus 1. t1 is the negative of that. So we can choose t1 is minus 1, t2 is plus 1. I mean, you can make opposite choices if you wanted to. I mean, this seems good just to have t1 less than t2. But we really care about, we go back to the problem, it says find the point. It doesn't say find the times, it says find the point. And so what do we want here? We want x of 1 is 1 cubed minus 1. Y of 1 is 4 times 1 squared. This is 0 and this is 4. If we plop in minus 1 instead in here instead of plus 1, we see we also get 0, 4. So that confirms that, yes, we did find the appropriate point. Okay, so we found the point. now the last thing we have to do is find tangent lines. So in order to find tangent lines, we should know, first we need dy dx. dy dx is y prime of t divided by x prime of t, because really this is dy dt divided by dx dt. It's kind of suggestive how the dt's cancel. That's a heuristic sketch of why this is true. And so what are y prime and x prime? Y prime is, bring down that 2, will be 8t. And x prime of t will be 3t squared minus 1. So this is our slope of the tangent line. So we want to plug in when t is equal to 1. When we plug in t is equal to 1 here, we end up with 8 times 1 is 8 over 3 times 1 squared minus 1. That is plus 4. When t is equal to minus 1, what do we end up with? Minus 8t divided by 3 times minus 1 squared minus 1. Oops, that should be an 8 times minus 1 is the clearest way to write that. 8 times minus 1 is minus 8 divided by 2 is minus 4. So we have two lines. They both go through the point 0, 4. So two tangent lines through 0, 4. The slopes are 4 and minus 4. So our final thing is to write down the equations of these lines. So we're using the y minus y naught is equal to m times x minus x naught. In both of these, x naught is 0. In both of these, y naught is 4. And our slopes are 4 and minus 4. Okay.